Now that we know how to work with individual components, we'll combine a few to make some real-world applications. The first project we'll be working on is creating a metronome. Metronomes are often used to produce steady beats while practicing music. Here's a metronome I use while practicing the piano. So on the dial we can see different numbers ranging from 40 to 208 beats per minute. So when I start my metronome, you can hear a slow audible click along with the flashing LED each time you hear a sound. As we increase the dial to higher numbers, we can hear the quick sound occur in a higher frequency along with the flashing LED. We'll be creating a metronome on this acrylic panel, and we'll be using the OLED display, buzzer, LED, and the potentiometer. The display will be used to show the beats per minute, the buzzer will make the sound, the LED will flash in sync with the buzzer, and the potentiometer will allow a user to select the tempo or beats per minute of the metronome. Let's take a look at the code that we will use to make this functional. So let's go over the metronome code. We start by including the library that will allow us to use the display and set up the display using an object, creating the display as an object from the library. We define the 3 pins for the 3 objects we'll be using, and we create some variables: on time, pitch, preval, and so these 3. So on time is how long each beep will be. The pitch is the sort of sound that's created, and preval is the previous value. So that way we can tell if the metronome is changing value, and we'll also update the display and change the speed of the sound. We'll also define a couple others without values: value, beats per minute, and period, which will be created from beats per minute. In setup, we use pin mode to set up everything. We begin the display and the serial monitor. We take val and set it equal to analog read of the potentiometer. And now we do the rest in an if statement. We don't want to keep updating the display if the potentiometer value hasn't changed much. So if the value has changed by more than 5, we know that this is due to a human. So inside this if statement, we use the map function, which will change a value between 0 to 1023 to be within a range of 40 to 208. The period is defined to be 1000, which is 1 second, divided by beats per minute divided by 60.0. The previous value we will set to value here, and we clear the buffer and use this area right here will be now used to draw metronome, beats per minute, and the number all onto the display. We send this and then have a small delay. If nothing has changed, then what we're going to do is we're going to apply a tone. We're going to use digital write to change the state of the LED. We wait for however long we want to keep it on, in this case 50 milliseconds, and write the LED as low. And again, we have another delay, except this time it's period minus on time, so it stays off for the rest of the period. We also print out to the serial monitor for debugging purposes, val and preval to the serial monitor. So let's go ahead and test this code out. Go ahead and see if the metronome code works. We're going to upload it and it should pop up shortly. And yeah, we see the word metronome in yellow on the display, and the BPM will be shown in blue. And so it's at 208, and I can move my metronome to 208. And we can hear that it's the same BPM, it's just slightly out of sync. We can also change this to a slower tempo, all the way down to a minimum of 40, which we can also test, though it's harder to tell with it out of sync. And we can go anywhere in between with little lag.